Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to take a look at fundraising thermometers. It's kind of similar to the thermometers you think about when you're talking about the weather outside. Only now, we're going to apply thermometers to data. Let's take a look at our sample problem. If we were looking at a fundraising thermometer, let's say in Mr. Lehner's class, there are 28 girls and 14 boys. That's a lot of students. One student stated that there was a 2 boys to 4 girls ratio in the classroom. Do you agree or disagree with this statement and explain? So we're going to take a look at the claim that the student made, and either we're going to try and prove him wrong or we're going to try and prove him right using math. So what I know is they're stating there's a 2 boys to 4 girls ratio. I can also write it as 2.4 boys to girls. Another way to write the ratio in there. I know it's also the fraction 2/4 because there's 2 boys to 4 girls. I can write it as 2/4. I can not simplify, but I can then find an equivalent fraction of 1/2. Another equivalent fraction would be 14/28. So using the equivalent fraction of 14/28, since it's equivalent to 2/4, I know that this student is correct because 14/28 would be the same thing as 2/4. So they're correct. There is a 2 boys to 4 girls ratio in this classroom. Now if you're a visual learner, so I kind of like to look at pictures to help me sometimes. It might be easier for you to make a thermometer. There were 42 total boys and girls in the classroom together. So in this thermometer there's 42 bars. 14 of the bars are blue for boys, and 28 of the bars are gold for the girls. So when looking at this, visually you can kind of see, well, half of this area is boys, the other half there is girls. So I would need to take 2 of these boys to make the girls section, which would tell me that it's a 2/4 ratio or a half ratio. If it's hard for you to break this one apart, take a look at the right side here. When looking on our right side here, I have my 28 girls in gold now, and I have my 14 boys in blue. If I were to create another blue bar and put it right underneath here, that would make this complete and even with this side. So this is another way to kind of prove how the ratio works, or why that student was correct in stating that there was a 2 boys to 4 girls ratio, which an equivalent fraction is a half. So this blue is half of the bar of the gold. Or if I look on this side, this blue, it would take up half of this gold here. It's just another way to visualize the information as you're trying to explain it. So that's something you can use as one of your strategies to solve these types of problems. Let's take a look at a problem that I want you to try. In Mrs. Regan's class, there is a 4:3 ratio of boys to girls. How many boys and girls could there be in this class? Is there more than one possible answer? Explain. So again, we're working with a word problem here, a real life situation. Go ahead and first analyze the prompt. What is the information that you are given in the problem? What is the problem asking you to do? Set up a strategy to solve that problem, and then is your answer or answers reasonable? Go ahead and get that pencil, get that paper, pause the video, and try this problem. Okay, as you're working through this problem, you know there's a 4:3 ratio of boys to girls. You're trying to find out how many boys and girls could be in this class, so they're not giving you a specific answer. Is there more than one possible answer? Yes, there can be multiple answers to this problem. You want to start off, you know that for every 4 boys there are 3 girls. And again, that's a key statement, for every. You're going to see that a lot throughout this unit. So I could write that as a fraction of 4/3. You're right, it's an improper fraction, but that's okay because we're using it just to talk about the number of students in the class. So 4/3, how could I get an equivalent fraction from 4/3? Well, if I double 4, I could get 8, but if I do that to the top, I have to do it to the bottom. So if I double 3, I can get 6. So 8/6 is an equivalent fraction to 4/3. So this class could have 8 boys and 6 girls. That would be the equivalent fraction to 4/3. What could be another possibility? Well, if I triple 4, I can get 12, but then I have to multiply the bottom by 3 too. So I can get 12/9. There could be 12 boys and 9 girls. Well, another possibility is, what if I multiply the 4 by 4 to get 16, and multiply the 3 by 4 to get 12? There could be 16 boys and 12 girls. I can then try multiplying by 5. I'd get 20 boys and 15 girls. Try multiplying it by 6. I'd get 24 boys, 18 girls, and 7, 28 boys and 21 girls. All of these fractions here are equivalent. So in Mrs. Regan's classroom, any of these answers would be acceptable. Again, you wouldn't want to get something like 145 boys and 120 girls, what the number would be. You want to make sure it was a reasonable class size. So any of these answers would have been reasonable as you were working through the problem. Hopefully you came up with a solution that was close to this. If not, double check the work and look at our fractions. Remember, fractions are our friends. Don't be afraid of these guys. Thank you for tuning in to Mr. Lainer's Math Extravaganza. As always, we'll see you next time.